Today we would like to discuss about the FIR harming window. Designed on a FIR bandpass filter to pass the frequency in the range of 1 kHz to 3 kHz and sampling frequency of 8 kHz with 11 samples. Draw the linear phase FIR filter structure. Apply the harming window. Okay. First, we are given the sampling frequency here is 8 kHz. And we have a cutoff frequency FC1 is 1 kHz, FC2 is 3 kHz from the questions. Okay, then we have the sample n equals to 11. So from the questions here. First step, find cutoff frequency omega C1 and omega C2 and also the HD exponential j omega. This omega C1 and omega C2 in digital domain characteristics. So we are using the formula omega C equals to 2 pi Fc divided by Fs. So 2 pi Fc, we substitute with 1 kilo if Fc1 divided by Fs, 8 kilo. So we cancel off, we get pi divided by 4. So 2 pi. So 2 cancel out with 8, we get pi divided by 4. And we also calculate the omega C2, 2 pi Fc2 divided by Fs equals to 2 pi 3k divided by 8k. So 2 cancel with 8, we get 3 pi divided by 4. Then we go to the next step. We will calculate the HD exponential j omega to construct this. So in order to construct this, we have these two frequencies, omega C1 and omega C2. So we have to draw it out. So how you want to draw it out? Okay. To draw out our magnitude response curve, okay, first thing, we have to draw the y-axis HD bracket exponential j omega. Then we have this question is a band pass filter. So the area that it allowed to pass is from pi divided by 4 until 3 pi divided by 4. So we are putting pi divided by 4 until 3 pi divided by 4 band pass. And then this question didn't let us know whether it's causal or non-causal. So we have to consider both parts. So when we consider the both parts, negative side we also draw from pi divided by 4 until negative 3 pi divided by 4. So negative 4 pi divided by 4 until negative 3 pi divided by 4 also is a band pass, allowed to pass. And then otherwise, other than these two areas, other areas is stop band. So we are drawing one line here for stop band. So from negative pi over 4 until positive pi over 4 also is a stop band. Until here also is a stop band until pi. So basically we have 4 parts. 1, 2, 3, 4, 5. Okay, 5 parts. So from here, so we can say that here is allowed to pass, we putting 1. Okay, so 1 when pi divided by 4, modulus omega because of negative and positive until 3 pi over 4. 0, so this 3 part is 0 otherwise. Okay, then we are going to find our alpha. So from the question, our m is equals to 11. So we're using m minus 1 divided by 2 formula. So we get 5. Okay. So now we construct our HD exponential j omega. Our new omega is 1 exponential 1 j omega 5. Okay, so we substitute our alpha with 5. Okay. Okay, then we go to the next step. Next step, we will apply the IDFT inverse discrete times Fourier transform. So HDN equals to 1 divided by 2 pi integrate pi minus pi HD exponential j omega multiplied with exponential j omega n dw. So just now we have five parts. So this one is our first part, second part, third part, fourth part, and fifth part. Okay. From this diagram, previously, so we know that part 1, 3, and 5 are 0. Okay. So now we just have to calculate for part 2 and part 4. Okay. So part 1, 3, and 5 are 0. So we just consider part 2 and part 4. So part 2 is 1 over 2 pi bracket integrate from negative pi until negative pi divided by 4 until 3 pi divided by 4 negative. Okay, so we have 1, so dot with exponential j omega n dw plus with another part 4 is 3 pi over 4 until pi divided by 4. So 1 point exponential j omega n dw. Okay. Then we continue. Okay. So we integrate it, we get exponential j omega n divided by j n because exponential has to divide. Same for another side. So our part 4 also exponential j omega n divided by j n. Okay. Then we substitute our limits inside. So we substitute negative pi over 4 and negative 3 pi over 4, and here 3 pi over 4 minus of pi over 4. Then we rearrange these two equations. We collect the 3 pi over 4 together, so we will have exponential j and 3 pi over 4 minus of negative j and 3 pi over 4. Okay, when we see this equation, we think about our Euler formula. Our Euler formula is exponential j and 3 pi over 4 minus of exponential 1j and 3 pi over 4. It will become sine and 3 pi over 4. Okay, and divide by 2 here. So from the Euler formula, divide by 2, so we will multiply by 2 at the side. Okay, same for the part 4. Okay, so same for this part. This part, we collect pi over 4 and minus of negative pi over 4. We also using the Euler rules. We have 2j sine n pi over 4. Okay. And then we simplify it. Okay, how we simplify it is we bring out our, this one, we have bring out our pi n. So we have pi n here. So this j and j we cancel off. Okay, because this one divide and this one divide with this one cancel off. Then we will have 1 divided by pi n bracket sine n 3 pi over 4 and sine n pi over 4. Okay, now this thing is from negative infinity until infinity is infinite. Okay, so it's infinite, we have to do for the next calculations. So next step, we have to find our HD in 11 samples. And also we have to, this one is our HD. Okay, so our H is find from our HD multiplied with our WN. So now our WN is a Hamming window. So given using Hamming window, So we are WHM. We have WHM here. So this one is our general formula. Okay, now HD is multiplied with window N. Okay, and our N is from 11. Our M minus 1 divided by 2. So this in this question is 11. So minus 1 divided by 2, we get 5. So now this question, we are using the Hamming window. So HM. Okay. Now we have to look back our question. Hamming window formula. Okay. This one is our Hamming window formula. Okay, for non-causa. So it's 0.54 plus 0.46 cos 2 pi n divided by m minus 1. So this one, n is m minus 1 divided by 2. So this one is, our m is 11. So here we will get 5. Here we will get 10. Okay, because it's m 11 minus 1, we will get 10. So we will putting our n value here. Okay. Then we are putting HDN equals to 1 divided by pi n sine n 3 pi divided by 4 minus sine n pi divided by 4 from the HDN just now. Then we putting our Hamming window inside, the formula of Hamming window. And then we put in our Hn equals to HDN and multiply with our Hamming window. So we get the answer. So now we're putting inside the calculator to calculate this answer. Okay. To calculate this thing, what we do is we have to let this one is 0 and we have to let it in limits. So we have to put it in 0.01. So we have calculator here. It's 0.4995. The 0.4999. So it's 0.5. Okay. Okay. So how we can is we put 1 divided by pi multiply with 0.0001 and then we multiply with, okay, sine 3 pi multiply with 0.001, then divide by 4 minus sine pi multiply with 0.01 divide by 4. Okay, and bracket. So we get 0.5. So 0.5 here, so we will put 1 over 2 lah, 0.5. And then we calculate for when n equals to 1. Okay, when n equals to 2, we substitute inside. When n equals to 3, so we calculate, we will get 0, negative 0.383, and we repeat, okay, until minus 5. Okay, same for here, we also calculate it to get the answer here. So how we do is, okay, so same also, we start with the calculation. Okay, so it's 0.54 plus with 0.46 cos, okay, 2 multiply with pi multiply with 0.001. This one no need to be 0, this one multiply with 1. They multiply with 0. Okay, this one 0. Okay. Then you divide with 10. Okay. Okay, you will get 1. Okay. So this answer 1. So this one no need to use the limit. This one just put in 0, 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5. Okay, you calculate, you get the answer for all. Then you repeat for here, 0.5 multiply 1, you get 0.5. 0 multiply 0.9121, you get 0. So here you do the same. Here you do the same. Here you do the same. You multiply, you get 0, 0, 0. Here will multiply, you get 0.2171 and then 0, 0, 0. Okay. Then you get your answer. So for your understanding, this is the step of calculations. Okay, so you just have to just out the HDN. You use the limit. That's why we say we use the limit by apply the hospital rules, or it's nearing to the 0. Okay, we'll get 1/2. And then when key n equals to 1, so putting n equals to 1, we get 0. So when n equals to 2, we're putting 2 inside, we get this answer. 3, putting 3 inside, we get 0. 4, we're putting inside, we get 0. And 5, we're putting inside. 5, we get 0. Okay. Same for here. We repeat the window. So we're putting when 0 inside, okay, 2 pi 0 divided by 10, so we get 1. And then when n equals to 1, we're putting inside, okay, 2 pi 1 divided by 10, so we get 0.9121. And we repeat for 2, okay. Then we repeat for 3, we repeat for 4, we repeat for 5. And then we multiply the HD and the window to get Hn. Okay, so Hn here, we will have 0.5. So this one, 0 multiply 0.91210. So this one multiply this one, we get 0.2171. Others are 0. Okay, after finish, then we go to step number 4. So step number 4, hash z hash 0, n minus 1. So m minus 1 divided by 2, summation m minus 1. So here is Zn and Z minus n. Okay, so from the just now questions, we know that we just have the value during 0.5 and negative 0.217, and that one is just for n minus 2 when n plus 2, and when your Z is power of negative 2 and power of 2. So we write down, this one is our hash Z, and then we find our hash prime Z. Hash prime Z, same also, we have the Z minus n minus 1 divided by 2, then we multiply with the HZ. So same for here, we just have to take the Z minus 5, multiply inside, so we'll get 0.5 become 5. So this one is 2, power of 2 and power of minus 2, so multiply with Z power of negative 5 plus, so negative 5 plus 2, we will get negative 3, negative 5 plus negative 2, we get negative 7. Okay, so this equation. Then we'll draw our linear phase FIR structural. Okay, to draw the linear FIR structural, so we will have this equation. First is 0.217 is Z minus 3. So we draw our X and input. Okay, Z minus 1, Z minus 2, 1 also lah. Second, Z minus 3. Okay, at the minus 3, we have go down the arrow. Okay, this one is negative 0.2171. Okay, then we continue 3, right? Okay, then continue Z minus 4, Z minus 5. Then 5, we will multiply with 0.5. Then you go down here and multiply. So this one no need to multiply. So we go in Z minus 6, Z minus 7. So from Z minus 7, also same, we have to multiply with 2171. So these two, we link up, add up. So only multiply with negative 0.2171. Then we link up here, we add up with the 0.5 here. Then the others that no need to draw lah, because just until Z minus 7. So our output is YZ. So done for this one. Then we go to next step to find our magnitude response realizations filter. Okay, we must remember this formula. Okay, so we will have modulus H exponential J omega n summation from m minus 1 divided by 2 n equals to 0. So an cos omega n. Okay, so here, this one, the value is get from the transfer functions. Like just now we do previously. So we will have 0.5 minus of 0.4342 cos 2 omega. Because just 0.5 we have the value and the other are 0. So we just consider the h prime 3 lah. H prime 3. Okay, so 0.432 cos omega. So this one you have to multiply with 2. Okay. Okay. Multiply the 0.2171 multiplied with 2. So we get negative 4342. Okay. Then we have this equation. And then we can either using angle. So if degree, you can use 0, 15, 30, 45 like that. Or you can using pi. If pi, you have to calculate in radian. So we can using either one to calculate. Okay, this one is using degree. So we put in, and then we substitute degree into these equations. So we will get the answer lah. So for example, the degree is 0. So we 0, so 0.5 here minus, okay, 0.4342 cos 2 times with 0. Okay, 0 here. Okay, bracket. So equal to 0.0658. Okay, put inside the value. Okay. Then to calculate modulus, we have to 20 log the answer. So 20 log this answer. So we will get negative 23.64. So here we plot negative 23. Here we plot negative 23.64, and we plot until finish. Okay, that's all until the magnitude response. Okay, thank you.